Alright, hello and good morning dear students. So today is 30th of July and today we are starting a very important topic in definite integrals, which is properties of definite integral. Now there are some properties from like 8 properties. We'll discuss one by one. The reason we are doing this is because many of the questions cannot be simply solved by integrating and putting the upper limit and lower limit. Some questions we have to solve by using the properties. And it becomes very easy when we use the properties of definite integral. These are, you can tell, like standard integrals, okay? But in case of definite integral, okay? So first is property 0. So see, you can give 1, 2, 3 also, but since it is given as P0, I am stating P0 out here, okay? So first property is integration a to b fx dx is equals to integration a to b remains as it is, but the variable changes from x to t or any of the variable. Just an example I am going to give you. Okay, let us go once again. Integration a to b fx dx. See, this fx is a function and integrating from a to b. It is same as a to b ft dt. For an example, if you find the value for 1 to 2 x dx and if you find the value for 1 to 2 t dt, the values will always be same, isn't it or not? Are you clear? So pause the video for a while and then think. The value for this and the value for this is always going to be same, provided the limits are same on both the sides, a to b, 1 to 2, 1 to 2. If it is x, then dx. If it is t, then dt. The same thing is out here also. So this is your property number 1. Even if I change the variable, but the same function, same type of function has to be there, okay? Here, x with t. It cannot be x and t square. If it is x square, it has to be t square. Sin x, sin t. Okay? And the limits has to be same. So whenever this kind of situation is there, then I can simply write integration of a to b fx dx is always equals to a to b ft dt. Okay? Pause the video and note it down. Okay, so likewise we have property number, another property that is P1. Now what does P1 says? A to b fx dx will be equals to minus b to a fx dx. So whenever I interchange the limits, when the upper limit will be lower limit and lower limit will be upper limit, then the value for the integral changes with a minus sign. You can see clearly out here, fx on both the sides. Okay, so for an example you can take 1 to 2 x dx. The value for this integral will be just the negative of 2 to 1 x dx. You can verify yourself also. Okay, so this is your property number 1. Once again, what is property 0? A to b fx dx is equals to a to b ft dt or any of the variable. If you want to take it as p, fp dp. If you want to take it as l, fl dl, fm dm. Okay, and so on. Second one, if I interchange the limits, the value for integral changes with a minus sign. Okay, 1. That is property number 0 and property number 1. Pause the video, note it down. Okay, we move to property 2 now. This is the third one. A to b fx dx is equals to a to c fx dx plus c to b fx dx, where a is less than c, which is less than b. So this condition, in this condition, this is true. For an example, let us take 1 to 3 fx dx. This can be, this 1 to 3 interval, I can break it as 1 to 2 fx dx and then again 2 to 3 fx dx in this way. So we can clearly see out here 1 is less than 2 and 2 is less than 3. Okay, so whenever I have limit a to b fx dx, I can always break it as a to c fx dx plus c to b fx dx. Continuation has to be there, and this number should be less than a. Sorry, this number should be greater than a but less than b, which means this c must lie in between a and b. Okay, so this is your property 2. Well, this is another property that is P3. P3 states that a to b fx dx is equals to integration remains from a to b, but the value for the function changes out here. Fx, from x it changes to upper limit plus lower limit plus upper limit minus x. A plus b minus x. Okay, so for an example, if I have here as 1 to 2 x dx, then it will be 1 to 2, how? 1 plus 2 minus x dx, something like this. If I am using property number, that is P3. If I am using P3. So what does P3 tells? P3 states a to b fx dx is always equals to a to b f of lower limit plus upper limit minus x dx. Okay, this is P3. Pause the video, note it down. Alright, let's move ahead. P4 is same as P3. P4 is same as P3. If you see, it is a to b fx dx. Here it is 0 to a fx dx. A to b remains as a to b. Here also 0 to a remains as 0 to a. And this we can now change as, see, this is 0 plus a minus x, isn't it? This is same as 0 plus a minus x. What is 0 plus a? A. So a minus x. It is same as this, only the lower limit. If the lower limit is 0, then you use in this way. So now you have to remember one by one. What was property number 1? Property number 1 was a to b fx dx. Limit remains as same, a to b, but ft dt. Number 2, if I interchange the limits, the value for integral changes with a minus sign. Number 3, a to b fx dx, I can break it into two integrals, a to c, c to b, where c lies in between a and b. Okay, 1, 2, 3. Number 4, a to b fx dx is always equals to a to b f of a plus b minus x. Okay, number 5, which is P4 out here. Okay, you can give a numbering yourself. I'm just going according to the book. P4, 0 to a fx dx is also same as P3, 0 to a f of a plus 0 minus x, that is a minus x. Okay, so when we do one by one problems based on this property number, so 1, 2 and 2, there's hardly any few problems, but starting from 3, 4 and 5 onwards, there are many problems that we have to do. So we'll take this property, problem based on this. We'll take this property, problem based on this. We'll take this property, problem based on this. Okay, so in that way we'll have to do, but remember the properties. One by one has to. Alright, the next one, that is P5. I'm not going with P5 because P5 is not so important. Okay, I'm straight away moving to P6 and P7. Okay, now P6. If you have to use P6, remember that P6 starts from 0 to 2a. Now you have to be focusing on the limits as well. What was P4? P4 was starting from, let me just clear this. P4, what was a P4? P4, okay, let's go with P3 as well. P3 was starting from a to b fx dx, right? P3 was starting from a to b fx dx, which was equals to a to b f of a plus b minus x, is it? This was P3. What was P4? P4 was starting from 0 to a fx dx, isn't it? Now which property to use, it depends upon the limits also. You have to check the limit. When the question is given, you have to check the limit, okay? P3, a to b fx dx. Don't worry, I'll tell you how to identify which property to use in which question, okay? P4, 0 to a. I'm just giving you the the techniques to remember. P4, 0 to a. P3, a to b. P6, P5 we are omitting. P6, 0 to 2a. P7, minus a to b. So I hope now you can see here also, if it is P7, minus a to a. P6, 0 to 2a. P4, 0 to a. Okay, and these are very important properties in ISC. Okay, maximum question comes from P4. Maximum of the question, you can also see in the examples, maximum of the question comes from P4, even P3. Okay, and this and this. So when you do the exercise, so we'll then divide. Okay, question based on P4 will do set of questions based on P6 and then P7 and P3, and then we'll finish this exercise as well. Okay, so now, I hope you're clear how to remember. If it is P3, a to b. Okay, by the way, what was P0? A to b fx dx is equals to a to b ft dt. Okay, so in this way you have to remember P2, change in the minus sign. P1, P2, you can divide the integral a to b as a to c, c to b, okay? And this was p3, upper limit plus lower limit minus x, p4, 0 to a, p6, 0 to 2a, and p7 minus a to a in this way, okay? So more two properties to go. If it is p6, it will start from 0 to 2a. So 0 to 2a fx dx, 0 to 2a fx dx, this has two values. One is twice of 0 to a fx dx when if f of 2a minus x equals to f of x. I'll explain you when we do the sums, okay? For the time being, you have to remember this. 0 to 2a f of dx has two values. One is twice 0 to a fx dx. This will use if f of 2a minus x is equals to f of x. So we have to verify, we have to check, okay? So before using this, okay, how we'll do is f of 2a minus x. We'll find the value for f of 2a minus x. If it is f of x, then the value for this will be this. If it is minus f of x, it will be straight away 0. Right now, I think so you might be having problem to understand how sir is writing this and how sir is writing this, okay? For the time being, I'm telling you, write this and learn according to the property. What is your P1, P2, P3, P4, P5, okay, P6, P7, okay? For the time being, you just remember. And when we do the exercise, I'll be telling you one by one. Okay, P4 is this. Now if a question comes, how to identify, I have to use P4 or either P6 or P7, okay? So there are many questions. We are going to divide the questions according to the properties and we will be solving it, okay? So don't get confusion. For the time being, just remember the properties. Why is this and why is this? Because of these two conditions. Similarly, P7. Now if we are using P7 I can only use if the limit is starting from minus a to a. Minus e to a f of dx is equal to twice of this, the same thing, and 0. But the conditions are different. It is not f of 2a minus x out here, but whereas it is, the value for this will be twice of this if this f of x is even function and 0 when f of x is an odd function. Okay, so even and odd, 0 if it is even this, if it is odd this. If f of 2a minus x is this, if f of 2a minus x is minus f of x, it will be 0. Okay, so this much for today. I'm just giving you all the properties. Write down all the properties in your copies, and tomorrow when we start the exercise, you have to be clear with the properties, okay? Very, very important for ISC. Every question comes from properties of definite integral, and I want you all to go through all the properties. All the properties are given in the book. You don't have to go through the proofs. Just write down the property. Property number 1 is this. Property number 2, 3, 4, 5, 6, and then 7. Okay? So this much for today. I'll see you tomorrow.